Hi there, my name is James Cumming. I'm the product line manager for virtualization and the VSR based here in EMEA. And today I'm going to show you the virtual service router alongside the 5620 SAM, deploying into new markets to expand your network in a very rapid way. So to give you the background we're going to talk about here, so the situation is you're a service provider with a European network and you want to expand into a new market. So in this case, we're going to expand into Finland. We've seen a market there. Traditionally, you'd do that by ordering a router, getting it shipped to site, installing it in the location, and deploying services onto it. But what we're going to show today is the ability to do that in a more rapid way by procuring locally some generalized compute hardware, installing it locally, and remotely deploying onto it a new POP, a new router, in order to deploy your services. And then when that market takes off and you see more benefit there, you can expand that router with just the touch of a button from your local centralized headquarters without any need to go to site. This is how it looks in the lab. So we've got a mixture of virtual service routers. And we're going to deploy our Helsinki router here on two different physical servers. Logically, we're going to run ISIS and segment routing, and we're going to run services over BGP, connecting the physical world through the SRA shown in the middle here, through the virtual service router here, as we generate it. Initially, we'll run that traffic, and there won't be a router there, so it won't go through. And as soon as we deploy our network, you'll see the traffic and the customer traffic coming to life. We're going to do this using the 5620 SAM, running both as an element manager and as a virtual network function manager. So doing both activities, and they both come as standard with SAM. We're also going to be using a vanilla OpenStack Liberty deployment. It's not been altered in any way. It's a standard out-of-the-box OpenStack deployment. And this is going to be split like this. So two control path virtual machines operating the individual single router, and they are split over two separate physical hosts. And we have a data path virtual machine doing all of the value-added services and all of the performance requirements here. And that's on server 1. And then we're going to deploy automatically a new data path VM onto server 2. And these are the actual servers that we're using here for the VSR. They're located in our Antwerp lab, and you can see them there. If we move over to this screen here, you can see the SAM element manager, the 5620 SAM, that you're all very used to using. It's been deployed for a long, long while now. And here we're showing the network that we've shown up initially being discovered by the SAM. So this is virtual routers and physical routers side by side being managed in exactly the same way. So a really low barrier of entry from an operational perspective for deploying virtualized networks. So nothing changes for your operations team here. It looks and feels the same. And then over here, we have the SAM Virtual Network Function Manager here, which comes as one of the web applications with SAM. And on this side is the OpenStack instance. So an OpenStack instance tab in our standard OpenStack Liberty deployment. And here we're going to see virtual machines being created. So let's create our router. On the SAM Network Function Manager, we have a Cloud Tenant tab, a Catalog tab, and a VNF tab. The Cloud Tenant tab here references our OpenStack environment. So there's a single line in here referencing this OpenStack environment just here. The Catalog tab here gives us all of the pre-populated templates and configurations we wanted for our virtual service routers to be created. And you pick whichever one you want from the catalog and just deploy it. And our VNF tab at the bottom here, this shows our virtual network functions that have been deployed onto the system. So if we create a new virtual network function, now a new VSR, a Helsinki router. So we go to Add. And you see at the top, we have a 3-step process. So we have a catalog process. So in our step 1, we pick what the VSR we want to deploy from the catalog. In step 2, we pick which cloud tenant environment we want to deploy that on. In our case, it's our SR Experts OpenStack environment. Then we go to our third and final tab, and here we input a name for our virtual network function. So it's going to be VSR PE5. We give it a discovery rule, and these are the discovery rules from within SAM, so that when you create your virtual machine, it prompts the SAM element manager to discover that node so that you'll see it appearing on the map over there. And we put in our IP address. This is our system address. So we enter that in. And you see further down here, we've got a whole collection of options here. These are our options created in our heat template, so a standard OpenStack heat template. And you can review them here, or you can edit them and change them if you want to. So if we wanted to change the software image we were going to boot, you could select them from a drop-down menu and change the elements as you went along. So let's leave everything as it is, and we hit create. So now what we've done is create our virtual service router. We're ready to deploy it. So we select it and click deploy. And we immediately see this changes to deploying. So we're going to deploy it now into our OpenStack environment here. So if I refresh my instances tab on OpenStack, you see that it is spawning my virtual machine. So it's creating my virtual machine. It's doing my data path virtual machine first. And now that is active, it's now creating my control path virtual machine, so the two of them. And if we go to the CLI, you can see on the console, it looks and feels exactly the same as an ordinary router. It boots up as exactly like an ordinary router. It'll be very familiar to anyone who's ever used any of the service router portfolio. Again, when your operations team come to use the device and come to log onto the device, the CLI is exactly the same. So as this boots up, you'll see it looks very familiar. While it's doing that, let's have another look at our SAM Virtual Network Function Manager. And if we refresh this, see it says create complete. It's finished creating the device. And if I double click into it, I see the elements, component elements that make up this device. So 3 virtual machines, 2 control path virtual machines, and 1 data path virtual machine, as this is running in distributed mode. So the VSR has 2 different modes, an integrated mode and a distributed mode. And here in the distributed mode, we have a virtual machine per element of the router. And in the integrated mode, it's 1 virtual machine for all of the elements combined. So we see the router is now booted. And you see over on the map, we've automatically appeared, the router has appeared here, has been discovered and has been brought into SAM management in exactly the same way as you would a physical node. But it's been done automatically for you. So now you can see we've already deployed our Helsinki router ahead of time. It's all working. Our traffic that we've created here to mimic the demand in Finland has been running the whole time. And as this router boots up, there we go, we see the traffic is now coming through our new Helsinki router that's been created. So significantly faster than deploying using traditional physical architectures. And as our sessions establish, we will see the traffic go up and meet the 18.6 gig that we're sending through. So very powerful solution, very quick to get into new markets, a very good way of addressing new areas in your network. So as we can see, we've now got our 18.6 gig of traffic coming in and going out. 18.6 is an arbitrary number we've picked for the test. The limitations of the virtual service router is significantly higher than that. We've just picked 18.6 gig to mimic the traffic. But what we're going to do now is increase this traffic. And for the purposes of the demonstration, we've set a limit of around 19 gig. And what we said with that limit is that once you reach 19 gig, I'm going to need another data path VM to handle this traffic. As I say, an arbitrary limit set for the purposes of the demonstration. So now we're going to up this traffic. So we're going to add some more traffic to the system to simulate some more load in Helsinki, some more demand from customers. We wait for the tester to set itself up. And we now see our traffic raises to around 39 gig of traffic. What we will see now is, as we reach 39 gig of traffic, our element manager within SAM will detect that I've hit this arbitrary limit that we've configured for the purpose of the demonstration. It will say that we've exceeded that threshold, and it will tell SAM Virtual Network Function Manager that I now need to create a new virtual machine, a new line card, a new data path VM to handle this traffic. So we'll see shortly, we'll get an alarm in the element manager. The element manager will tell the network function manager. The network function manager itself will tell OpenStack, and we will spawn a new virtual machine, create a new data path VM, and bring that into service and service our new demand from our customers. All automatic. No longer do we need to order a new line card, get that shipped to site, get it installed. The system will detect that I have this requirement. It will automatically create it. It will automatically deploy it. So we see we've just got the threshold alarm now, so threshold is crossed. If we have a look over here, we'll see over on the OpenStack tab that we are already created our second data path VM here. It's already active. And if we resynchronize our setup on SAM, we see we have our second data path VM present, already configured, already into the network. So very, very fast to deploy new services. The other thing I want to show you today is our control path resiliency. This is a router. You're going to be running it in a service critical environment. So we need to be able to ensure that we have some control path resiliency available. So what I'm going to do is I'm going to remove one of the control path virtual machines. Now we would expect that if I was to do that in from the SAM element manager, that would happen in a relatively smooth way and there would be no issues. So what I intend to do is to disable the first primary control path virtual machine. And I plan to do that ungracefully within the OpenStack dashboard. So our SAM element manager is not doing this activity. So to simulate essentially ripping out a control card. To do that, we're going to look at our traffic statistics. So if we now go to our traffic statistics here, we're going to reset our counters to show that our drop frame counters here is going to be 0. And we're running this traffic still. We're still running the 39 gig of traffic. And when I do our control path resiliency, our fail of that control path, even ungracefully, that number should remain at 0. So let's do that. Here is my control path A module. It's my first control path module. It's the one I'm currently active on. So let's shut that down within OpenStack. So you'll soon see this will move to shut down. It's now in shutdown state. If I resync my element manager here, we see that SAM now understands that it's suspended. I've pulled out of my device my primary control plane, the thing that was controlling the whole router, and we still see that we're still running with 0 drop frames. So we haven't lost any frames at all in doing that, complete control path resiliency. And if we go back to our traffic graphs, we'll see that we still have the 39 gig of traffic going in and coming out the other end. So completely hit this control path resiliency. So that is the virtual service router being used to deploy networks into new markets in a very rapid way, significantly exceeding the time to market you would have in a physical router deployment. So thank you very much for your time.